Hello, everyone. Welcome to my talk. And today we will be talking about Git and changelogs and automation. So let's jump right into it. Who am I? I'm Orhun Parmaksız, mostly known by my name, Orhun, on social platforms. That's my real name. And I'm an open source developer for a couple of years now, mostly working with Rust and other languages as well, but I like Rust, so yeah. I'm a maintainer at Ratatouille, which is a terminal user interface library for Rust. You can build very beautiful dashboards, and you can just do many crazy things on your terminal with Ratatouille. I'm a creator of many other open source projects, including Git-Cliff, which I will be talking about today, Kmon, GPG2E, Systoroid, Dactylo, and many more. I'm also a package maintainer at Arch Linux and Alpine as well. I've been trying to improve the Rust ecosystem and Rust tooling for the users of these distributions for the past couple of years now. And I'm also a paid open source contributor at Shuttle, which is an infrastructure company, and it's basically Versal for Rust. So yeah. Here are some of my projects. You might have come across them on GitHub maybe. And I mostly work with terminal and command line. And yeah, I like creating developer tools and writing Rust, basically. And sometimes Zig as well. Today's schedule is, first I will give you the description of the problem that we are going to solve, and I will go through the possible solutions. And through the end of the presentation, we will be seeing how Git-Cliff became Git-Cliff, and I will also give you a demo implementation. So there will be some Rust coding as well, and we will be creating a very small Git-Cliff, essentially, and we'll see how it is implemented, how it can be improved as well. So let's start. Let's imagine a developer. They use Git, luckily, good for them. They use conventional commits. Let's pretend they use conventional commits. So what are conventional commits? To give you a quick introduction to conventional commits, it's basically this format. So you have a type, an optional scope, a description, body, and footers. And for example, we have a feature here. It's a feature on life, and it's a breaking change because of the exclamation mark. And the commit body or message is the set the computer on fire. So this is a conventional commit, and it has many advantages. While you're using Git, it makes it easier to differentiate between the different parts of the code base and so on. If you want to learn more about conventional commits, you can go to this site, basically. And let's imagine this developer also uses semantic versioning. And what is semantic versioning? It's basically a version scheme where you have you have three different parts in a version, and they are separated by dots. First one is major, and second one minor, and patch. And how it works is that if you have a breaking change, you increment major version. If you have a feature, you increment minor. And if you just have a patch, you just increment patch. So it's a very convenient way to show what you have added in your software, and it's a very easy way to have different versions and tell your users that you have maybe a breaking changes or new features and so on. If you want to learn more, you can go to samar.org, which have all the useful information and more there. And let's imagine our developer also likes automation, and yeah, we all do, so great. And they want to create a release for their open source project, closed source project, whatever. They just want to create a release and get their software out to the world. How about changelogs? Like, what are you gonna do? Like when you create a release, you want to let the users know that you have changed some stuff. So changelog comes into place. But before jumping right into the changelog generation and changelogs, let's take a look at the description of changelog. So changelog is according to Wikipedia, it is a file that has all the notable changes made to a project. It contains the bug fixes, new features, and so on. So most of the open source projects today, they maintain a changelog file in the repo, and it is usually a markdown file. And it's like when you clone the repo, you can see it in changelog.md. So that's basically the changelog. To give some example, there is one release from the regex crate, Rust regex crate, and it says that this is the 0.1, 1.0 release of the crate of the project, and it has all these changes, and it has some important changes. So the author wants to outline them by having sections here and just a paragraph explaining what has changed in this version of this crate. So this is a changelog. Also, this is a changelog as well. This is from my project, Menyoki, and this follows the keep at changelog format. So in the changelog, we have the date and version, and then we have like a couple of sections here, and these sections are, according to the keep at changelog format, they should be added, changed, removed, maybe a security. I'm not really, I don't remember right now, but you have different sections, and if you follow this format, it's a keep at changelog format, and it uses semantic versioning as well. This is, as you can see, more readable compared to the one that I showed you before. It doesn't have a paragraph. It just have the messages and the commit messages, and just grouped by their type and whatever. So yeah, this is like more readable. So the question comes into place. What are these entries? They are Git commits, right? So we can simply like automate them, right? So why not do that? Today, there are a couple of ways to automate this process. First one is, and the most straightforward one is using the GitHub interface. So if you want to create a release on GitHub, it has this button, and if you click it, it will generate a changelog for your tag, and it automatically detects your previous tag and compares the history and generates this markdown formatted file, and you can just add it to your releases. But there are a couple of downsides of this approach. First one is you have to be like using GitHub, obviously. Second one is you need to be using a pull request based workflow, and otherwise it won't, the comments won't appear in this output. So as you can see, there are like PR links here, so, and also the author usernames and so on. So you have to be using GitHub, and you have to be using pull request based workflow, and also you need to be using the interface, which is not great. You can't really do this from command line, as far as I know. So yeah, it's not ideal. So command line, we have this very obscure git command, git short log, and it outputs this to your terminal. This can be used as a changelog, but the commits are simply grouped by the committer name, which is not very ideal. Also, it's a very verbose output. I would like to like group some of these commits, maybe have some better formatting. So it's not ideal again. There are also like other tools that you can use. Most of these tools are written in Rust and aim for Rust projects, but there are like much more simply, and they're working great. They're fine, but today we will be giving a different approach to the changelog generation. So we identified the problem. The problem is creating a changelog is a tedious task. It might take some time if you want to do it by hand. You're giving giving overview of each like change to your project and writing everything down. It's takes time, you know. So if you're using conventional commits and semantic versioning, the idea is that we can automate everything, generate a changelog from your Git history. So this is the problem that we wanted to solve. Let's take this Git history as an example. It's the output of Git log and some formatting. And you can see here there are some commits. It follows the conventional commits specification. It follows somewhere. There are like 2 tags, and it's a very it's not a big project, so to speak. It's just a couple of commits. So what we want to do is take this and turn it into this format. This is Markdown. It's a much readable format. As you can see, what we're doing is basically taking each commit, processing them, and turning them into this beautiful Markdown. So Changelog is just a beautified Git history. Well, not always, but this is what we're aiming to do today. So Git-Cliff. Let's talk about Git-Cliff and how it does things. But before that, let's imagine a developer again. They write Rust. Good for them. They created a cool project, which comes by default if you write Rust. But that's not what we are going to talk about today. So yeah, there might be some Go people in the audience. They want to create a changelog. So what do? Well, this was me back in 2021. I created one of my first Rust projects. Not first, but I created a Rust project. It was I was looking for ways to create a changelog, but I had some issues. So the project that I mentioned was GPG2i, hydration break. While you watch the GIF. So what I aim to do was create a terminal user interface for GPG, and this is how it turned out. And everything was great. I was about to release the first stable version of GPG2i, so excited, but something was missing. I wanted to automate the changelog generation, because until that point I was just copying the stuff from Git history and changing the format of things and having a changelog. But since I'm a bit obsessed with automation, I just wanted to automate this. Found out there's one tool called Glu. You can use it to pretty much do the thing that I mentioned. So it generates a changelog based on the state of your Git repository. Great. Conventional commits into human-readable changelog. This is also great. Uses Git tags. Nice, and you can customize it, apparently. That's also nice. And also, this is a binary, and you can automate this by adding this to your CI. All sounds great. I was very excited to try out Glu, and I did. This is a output from Ratatouille. I used Glu to generate this Markdown changelog. It looks nice. It's usable. It is not exactly, but something that I wanted. So I wanted to went a step further and customize this changelog. What I found out was you needed to have a template MD file in your repo to customize the output that Glu gives you. This was not great because it means that you have to maintain another Markdown file in your repo to customize what you get from Glu output. And Glu also didn't support parsing command line arguments, so there are no arguments, and you can't really do anything to customize the output. So not great. So what do I do? Just go to the repo, decided to contribute, but the project was inactive. I packaged their software for Arch Linux anyways and just gave them an issue, but no activity. So I was pretty much stuck again. And on May 8th, I have a friend group where we discuss some project ideas. And I wrote this, let's write a decent changelog generator. I can't find any good ones. Well, it doesn't mean that the other ones were not decent or not good enough. But I was just thinking, maybe if I cannot find the thing that I was looking for, maybe I should try writing that thing. So this is what I meant, and decided to go with this project. Yeah, that's how all it started. So let's break it down into multiple steps. What do we need to do to have a changelog generator? So first, we need to open the Git repository, which means we need to read the contents of the repo, which is in the .git folder in your project structure. Second, we need to parse the commits. And third, generate changelog, and fourth, just profit. So let's go through the steps and see our available options and how we can generate a changelog. Well, on like next day I wrote that message, I actually went ahead and implemented a very simple changelog generator. And today we will be I will be changing this a bit and going through each step. So what was the first step? It's just opening the Git repo. Today there are a couple of options that we can choose to do this. First one is Git2, which is bindings to Git2, libgit2. It's basically like a Git library, and Git2 RS is just a bindings to it. So you need to have Git2 installed on your system to use this library, which is not great. Second one is Gitoxide. Gitoxide is the pure Rust implementation of Git, and it sounds like a better option, right? It's actually the best option, but at the time I was writing Git-Cliff and I was dealing with Git stuff. Gitoxide was not feature complete, so I just needed to go with Git2. And third option is just running Git commands and parsing the output, which is, yeah, let's not do that. So Git2, what are the downsides of Git2? And yeah, like I said, it requires libgit2 to be installed on your system. If you want to vendor libgit2, you have to deal with some feature flags and static linking and stuff. Also, you need to you can do stuff with environment variables, but you need to do some stuff basically. So it's a bit hard to work with, but it was the best option at the time. And today it's I'm not saying it's not usable, it is usable, but today if I was writing something like this, I would choose Gitoxide. So to use Git2, just add Git2 to your cargo toml, which is your project manifest. This is the latest version while I was preparing the slides. And then what we do is we parse the environment variable for the repository path. You can give it a hard-coded value, of course. And then we open the path, and this is what I mentioned about the .git folder. So it opens the .git folder and parses the contents. And then we create something called revwalk. Revwalk is simply an object where it enables you to traverse the Git history and objects inside the Git repo. And then I set some sorting flags, and I want to use the Git history sorted by time. So I just set that, and I push head, which means I want to start from the end of the Git repo. If you work with Git, you probably know what head is, and that's just saying that I want to use head as the starting point. Step 2 is parsing the commits. So you can have a lot of logic here, and there are a couple of ways to do this. But the simplest way of doing it is simply creating two vectors and going through each commit message and checking if the commit is starting with something or contains something. So just to demonstrate, here I am creating two vectors for fixes and features and going through each commit in the repo, and then I'm taking the message of the commit, and if the message starts with feat, which is short for feature, I just push it to the features vector, and if it starts with fix, I just push it into the fixes. So it's very simple logic. It just, at the end, just creates two vectors, populated with the commits. So this is the output. Fixes contains a commit which starts with fix, and the features contains the commits, feature commits as well. Just to give you an idea, here are the fields that you can access using Git2. So we use the message, but you can also use like the summary and header and committer info, author info, a bunch of like stuff that you can use using Git2. Also, here's the commit object that I'm using in Git-Cliff. So it's a wrapper for these fields basically. Some of them are just straight up coming from Git2. So just to give you an idea what you can do with the Git objects, here are the list of things. So step 3 is actually generating the changelog. To do this, I created this inline function closure, and it takes the vector of commits that we created in the last step and turns them into the vector of strings and formatters them with according to the markdown format. And after line 17, we basically push some markdown headers, and then we call this function to generate a section for fixes, and then at the end we do the same for features, and that's pretty much it. I decided to go with a inline function because I didn't want to like create another function, but yeah, just some opinionated implementation at this point. And finally, we just printed out to std out and joining the vector of strings. So this is what we get if you run everything. It is a markdown formatted changelog which contains all the commit information. And yeah, if you want to give it a try, here's the QR code and the link to the gist, and you can implement your own little changelog generation program this way. So we have our small Git-Cliff, and it's working fine. It's not very advanced, but we have basically like a small version of it. So let's go through what Git-Cliff is doing different from this approach, because I basically started Git-Cliff by running this little program. So in Git-Cliff, we have like three operations. First one is the configuration, and for the configuration part, it parses the command line arguments and the config file. And next one is Git handling. In the Git handling part of things, we process everything basically and created something called release context. And release context is simply giving to a template engine, and the template is being rendered. And this is the third part. It's the generator part, and then you have your changelog basically. Some of the libraries and the stuff that I use to do this is like argument parsing is clab, configuration is toml format, Git handling is Git2 like I mentioned, and the most importantly, the templating is handled by a Rust library called Terra, and it's based on Jinja 2 and Django templates. So we have this Git history. We basically turn it into this. So this is the release context. If you look at it, it is containing all the information that is needed to generate a changelog. For example, it has the message, it has the group, which is for the first object, it's documentation, and then it has the scope, and for other metadata such as author and committer, we also have it. And we give it to Terra, and Terra is, like I mentioned, it has some expressions and statements and like many things that you can do with Terra. And just to give you an example of what it looks like, this is one of the examples from the Git-Cliff repo. So if you want to go through each section here, the first one is taking a version. There's a version in the context. It takes the version, checks if it exists. If it exists, just puts it into a header in the Markdown file, and it takes the timestamp and formats it based on the date format. Next, if there is one previous version, it also adds a section to the Markdown file, and it's like the previous version and 3 dots and the current commit ID. So it's like checking, like adding a link to the changelog where you can click and go the difference between the old version and the new version. And the last part is you have the actual grouping and actual changelog generation. So this part is simply have the groups. So as you saw before, the documentation, and then we go through each commit here, and then we put it into the changelog as entries. So this is how it looks like. Also, you can have like macros in your template, which is also interesting. To handle the parsing in Git-Cliff, I'm using regular expressions. So as you can see here, we did like we in our simple program we had the logic where we checked the beginning of the commit message. So it's here it's the same. If it starts with feat, it puts it into groups. If it starts with fix, it puts it into bug fixes, and so on. And you can also like skip commits and override different parts of the commits as well. So with the previous template, it generates this file. Also, you can do stuff like this. This is from Git-Cliff itself, the repo, and this is another example of how we can do different things. And this is from Ratatouille, and this is so we decided to have the commit description and commit body in the changelog because we have we put some useful information there. So you can also like put that into your changelog, change the format in the whatever way you want. So that's possible. So let's say you want to like integrate Git-Cliff into your project. What's needed? It's very straightforward. You just install it with Cargo or your favorite package manager. You run git-cliff -init, which creates the cliff.toml file, and you just edit it with your favorite editor, which is Vim probably, and you just create the changelog with the last command, or you can just output it to stdout by just running git-cliff, and that's it. There are like a lot of examples, like example cliff.toml files in the repo, but this is the workflow. In the cliff.toml file, there are 2 sections. One of them is changelog, and it contains the body, which is the template, and other information. You can also like post processors, which are used to manipulate the changelog after you generate it. So in this case, it's replacing a pattern with the actual repo URL. The other section is Git, and this section is mostly related to your commits. For example, you can have commit pre-processors, and here I'm just I have this pattern to replace the numbers, like the PR numbers, with the actual repo URL. And also there's one pattern which is kind of interesting. On line 13, we are running a command for each commit before we generate the changelog. So in this case, it's running typos, which is another Rust binary, and it takes each commit, fixes the typos before wiring it into the changelog. So yeah, and also we have the commit parsers, as I mentioned before. this is the continuation. There are some flags. You can skip tags. You can ignore some of the tags, and so on. These are the possible ways of using Git-Cliff. First one is using the unreleased flag, which generates a changelog for your unreleased changes. So if you don't want to generate the whole thing, you just give this flag and just gives you the unreleased part. You can set a tag for your unreleased changes. So if you know the tag before you create the tag, you can just use this flag. There's another cool feature which I added previously. It automatically increases your version before creating the changelog. No, it just it uses the increased version in your changelog, and it uses does that by the magic of semantic versioning. So if you have like breaking changes, it increments the major and puts it into your changelog. You can also like for monorepos, you can include some of the parts of your code base into changelog, or you can exclude them. You can have a changelog for a specific range of commits, and lastly, you can print out the changelog context to std out if you want to do something else with the output. There's another use case which is using it as a library. Release Please is one of the good examples of that. It's a PR-based release tool made by Marco, and it uses the Git-Cliff core library, which is what Git-Cliff depends on. To use it, basically, you add this to your cargo toml, you import some things, and then you simply call the generate and changelog functions and objects into your Rust code, and just gives you, based on the commits that you give, it gives you the changelog. Also, I wrote a blog post about all of this, including some of the more automated like Rust tools. You can just read my blog, my post about this by going to this link. So what's the future for Git-Cliff? First, I would like to actually switch to GitHub side, because Git 2 is not holding up well. I would like to use a pure Rust implementation of Git, and this is actually ready. Byron created an issue on his repo, and all of the features that I need are there, so I just need to go and implement it. Also, I would like to create a web interface for Git-Cliff, which you can just go, give your GitHub URL, and generate a changelog based on some config. This is also done, but it's like a POC, so I should just work on this a bit more, but I don't like front-end stuff. But we'll get there. So yeah, I would like to thank everyone that started Git-Cliff and used it. And if you want to like support my goals and support my other stuff, maybe you can just go ahead and sponsor me. I am like very close to reaching my sponsor's goal, so please consider. So shout out to these awesome people who sponsored me, and thank you for your listening.
Thank you, Orhun, for sharing your work. Does anybody want to ask a question? Comment?
Work?
Yes, I guess. Try.
So the web page for Git-Cliff, is it running completely in the browser, or do you have a backend for it?
It's a good question. So I need to. So in order to generate a changelog, you just need the Git history, and for GitHub we can just use GitHub API. So we don't need to actually need a backend. We just make some calls to GitHub API, gets the list of commits, and then with the library of Git-Cliff you can just generate the changelog. We don't have to do anything on the backend actually, but yeah.
And the library is compiled to
WASM,
WebAssembly, I guess?
yeah.
Nice.
Any more question? Be shy. Okay. Okay, I guess it's okay. I guess it's fine.
Yeah.
Thank you again, Orhun. Thank you everybody for attending this talk.